Hey everyone, here's me explaining to you on if irrational numbers are real, and are irrational numbers really irrational? Now, what exactly do I mean by an irrational number? Well, if you understand mathematics if you're more familiar with mathematics, you would know that an irrational number is a never-ending decimal number that has no repeating pattern. Numbers like this are very common, like square root of 2, square root of 3, square root of 5 perhaps, or pi, or the number e. For e Eulers, I don't understand much on that one, but the number e is also irrational. The number is endless, but it has no repeating pattern like 2, 3, 2, 3, 2. But is this possible? Can numbers be really irrational? Is it a contradiction? Will there have to be some point where they meet up and it's no longer irrational? Number one rule is that you can never prove a number is really irrational. Perhaps we realize that numbers like the square root of 2 or pi is a rational number. But what if it does have a repeating pattern far, far away in the number? It is so far away in the number, it has a repeating pattern like 1, 0, 1, 0, 1, 0, 1, and that goes on for infinity. And that they found like a place where it repeats. But then again, even if you found that, you also cannot prove that, because somewhere between those 1s and 0, 1, 0, 1s, there might be a 2 hidden inside it, or a 3, or a double 0 hidden inside. So you cannot really prove these numbers are limits, are really rational again. Because 1, 0, 1, 0, 1 might look like a repeating number. It might have a 2 in between. Even if just the number 0.10101 was just a repeating number, it might have a secret 2 in the middle. Then it might have another secret 2 somewhere else. And the location might be unpredicted. It might be closer, further away, and you don't really tell. So not only can you tell if a number is really rational, but you also cannot tell if that number is really, really rational as well. It might be irrational, but then again, it might also be rational, because what if there is no way to make a number irrational? So are irrational numbers really irrational? For example, if I have 10 digits, then 100 digits, then all the 10 digits are different. Well, then I have over 10 factorial ways to do this. If each 10 digit of 10 different characters, numbers of 10 factorial ways. So that's 3,628,800 different possible sets of these to make every arrangement possible. But with infinity, is this even possible? What does it say? And will we run out of them? In fact, we will run out of them if we are not allowed to use two of the same numbers next to each other. If two same numbers are not allowed to be next to each other and have a maximum limit of 10 before using the same number again, that number will run out eventually. Or even if it didn't, even if it had switched way, it might run out if you don't use the same numbers. If the numbers are different next to each other each time, you will run out of the numbers, guys. However, if they're next to each other, that really doesn't stop you. Because then again, you can have 1 followed by 10,000 zeros, then 1, then followed by 10,001 zeros, then 3. Then you can have all sorts, you know. There might be one path where it's just full of 2s. One of the 2s could be changed into a 1, you know. As the infinity number sets are, how much exactly are there? And the number that we're looking at, is it really irrational? And what is the chance of part of a different irrational number to be contained within that irrational number, like a part that you don't see? For example, pi is 3.14, and square root of 2 is, of course, square root of 2 was, oh my days, 1.41, I think. So you might find 1.41141 somewhere hidden. The entire, over 10,000 digits of the square root of 2 might be contained in the pi digits. Then again, you do not know how far you would go. No, how far does it extend, and how much digits of pi do you need, you know? And is, again, irrational? Or would the numbers have to come to a certain perspective where it cannot be irrational, and irrational numbers is a contradiction? I'll speak more about that later on. Hope you enjoyed the video, guys. See you guys. Bye.